So we've just looked at inverse trigonometric functions for cosine, sine, and tangent. Now we're going to look at the inverse trigonometric functions for secant, cosecant, and cotangent. We'll be finding values of our inverse, secant, cosecant, cotangent functions. We'll find exact value of composite functions involving inverse trigonometric functions, and we'll write trigonometric expressions as an algebraic expression. So before, when I was doing the inverse trigonometric functions for cosine, sine, and tangent, we looked at the graphs and we went about it that way. I'm going to do a little differently for these other trigonometric functions. And so I'm just pulling up here the definitions of our inverse trigonometric functions for secant, cosecant, and cotangent. So it says y equals secant inverse of x if and only if x is equal to secant of y. So if we took the secant of both sides of that equation, we would get that. So where the absolute value of x has to be greater than or equal to 1. And so that is saying x is either greater than or equal to 1, or x is less than or equal to -1. And our y value is between 0 and pi. We have to be careful because secant of x, that is 1 over cosine of x, and cosine of x is equal to 0 at pi halves. So we have to say that y doesn't equal to pi halves. Same idea for our cosecant function. And before I go into that, let's just talk about this between 0 and pi. So remember that secant of x is 1 over cosine of x. Cosine of x, we looked at the inverse function, was 0 between 0 and pi. We limited the domain. So we're doing the same thing for its reciprocal trigonometric function. And now you'll see that when we're looking at cosecant inverse of x, this is if and only if x is the same thing as cosecant of y, where again, x is greater than or equal to 1. And so remember, cosecant of x was 1 over sine of y. Inverse function for sine y, we put between negative pi halves and pi halves, so that it was 1 to 1. And so we need to limit that domain for cosecant of x to be between negative pi halves and pi halves. And we also have to say that y can't equal 0. That's because sine of 0 is 0, and 1 over 0 is undefined. And then y equals cotangent inverse of x if and only if x equals cotangent of y. Here we have between negative infinity to infinity, and it's between 0 and pi. And so just think about the denominator of cotangent of x is cosine of x, and cosine of x we bounded between 0 and pi. So for the inverse function, our range is going to be between 0 and pi, not including. So let's look at a couple of examples. So if we had cotangent inverse of 1. So I have to think to myself, what is cotangent? Cotangent is sine over cosine, so this is between 0 and pi. And then I think to myself, which value would give me back 1 for cotangent? And that would be at pi fourths. And that's between 0 and pi, so pi fourths is our answer there. If we had cosecant inverse of -1. So I always tend to think of our cosecant, secant in terms of sine and cosine. Cosecant is in terms of 1 over sine. Sine, I know for the inverse function, for the original function, we bounded between negative pi halves and pi halves. So it was 1 to 1. So I need to figure out for cosecant, what value of cosecant would give me back -1 if it's between negative pi halves and pi halves. Well, I know that sine of negative pi halves is -1, so 1 over -1 is -1, so this would have to be negative pi halves. Some of these questions you need to use a calculator. I probably won't have any of those types on a test, because a lot of the tests you're going to have to do this without a calculator. But let's say that you did have one that wanted you to evaluate this for like your homework with a calculator. So for example, if we had cosecant inverse of 5. Well, I don't know what angle cosecant would give me back 5. And so this is where we want to use the calculator. The problem is that our calculators only have the inverse function for cosine, sine, and tangent. And so I can't just go ahead and plug this right into the calculator. And so let's rewrite this a little bit. So recall cosecant inverse of 5. We can rewrite this. This is the same thing as 1 over sine inverse of 5. And so we can look at that to figure out what this value is now. So we would just take 1 divided by sine inverse of 5. Okay, so what I stated was totally wrong. And I knew something was off, so I just needed to go and verify, but maybe this will help you so you don't do the same thing. So let's look at this cosecant inverse of 5. Let's rewrite this. So let's let this equal to theta. And so now let's take the cosecant of both sides. And so if we take the cosecant of both sides, so the cosecant of cosecant inverse of 5 is equal to cosecant of theta. Okay, so cosecant of cosecant inverse is going to undo itself, leaving us with an argument of 5. So 5 is equal to cosecant theta. So let's rewrite this in terms of sine. So this is the same thing as 5 is equal to 1 over sine theta. Let's multiply both sides by sine theta. So doing that, we get 5 sine theta is equal to 1. Divide both sides by 5. I get sine theta is equal to 1/5. Now I can take the sine inverse of both sides. So sine inverse of sine is just theta is equal to sine inverse of 1/5. And so now we can plug this into the calculator. And if you do that, you get that this is approximately 0.2. Let's just look at one more. So let's say we had cotangent inverse of 2. So again, our calculator doesn't have cotangent inverse, so we want to rewrite this. So let's let this equal to some theta. Let's take the cotangent of both sides of our equation. So cotangent of cotangent inverse of 2 is just 2. is equal to cotangent of theta. So let's rewrite that in terms of sine and cosine. So this is 2 is equal to sine theta over cosine theta. If we multiply both sides by cosine theta, we got 2 cosine theta. I made a mistake. I need to slow down. Cotangent is not sine over cosine, that's tangent. Cotangent is cosine theta over sine theta. So we're multiplying both sides by sine theta is equal to cosine theta. Divide both sides by cosine theta, we get 2 sine theta all over cosine theta equals 1. We know how to, our calculator has tangent inverse. So let's just divide both sides by 2 or multiply both sides by 1/2. We get sine theta over cosine theta is equal to 1/2. Well, that's tangent theta is equal to 1/2. So if we take the tangent inverse of both sides, we have tangent inverse of tangent is just theta is equal to tangent inverse of 1/2. So plugging that in the calculator, make sure that your calculator is in terms of radians and not degrees when you're doing this. This was cotangent of 2, which is approximately 0.46. Okay, so let's look at some other examples where we're having a composition of multiple trigonometric functions, one with a original trig function and one with a inverse trig function. So let's say that you had sine of cosine inverse of 1/2. So following says, find the exact value of each expression. So all of these, again, you should be able to do without a calculator. Some of these, we won't know what the angle is. This one we should, though. So here we have cosine inverse of 1/2. So you're thinking backwards. Cosine of what is positive 1/2? Cosine inverse, or cosine has to be between 0 and pi. And so the value would be pi thirds. So this is sine of pi thirds. And sine of pi thirds is √3/2. Let's say you didn't know the angle. Let's say we had tangent of cosine inverse of 1/3. And we want to find the exact value. We don't want to use a calculator. So the trick on these, let's choose something to equal this cosine inverse of 1/3. So let's say theta is equal to cosine inverse of 1/3. So I could rewrite this right now as tangent of theta. That doesn't really help me quite yet. And so let's go back to what we let theta be, and let's take the cosine of both sides. Here we would have then cosine theta is equal to cosine of cosine inverse of 1/3, which is equal to 1/3. So I know that my cosine theta is positive, so this has to be between 0 and pi halves. So I'm in the first quadrant. This is where we're going to go back and use our right triangles. And so if we look at our right triangle, theta is in quadrant 1. So this will just help me remember what my value, if positive or negative, for my trigonometric function. And so if I write my triangle, recall cosine is adjacent over hypotenuse. So my adjacent side of theta is 1. My hypotenuse is 3. And so we're going to use that Pythagorean theorem to help us figure out what the opposite side of theta is. And so we know that the opposite side, maybe let's just call it b for now. This is equal to the square root of the hypotenuse squared, 3 squared, minus our adjacent side squared, 1 squared. So b is equal to square root of 9 minus 1, which is the square root of 8. We'll notice that there's a factor of 8 that's a perfect square. This is the same thing as 4 times 2, square root of 4 times 2. So we can break this down as 2, root 2. So now we're going to use that triangle to figure out what tangent theta is. We know tangent theta, that is opposite over adjacent. And so the opposite side of tangent we just found was 2 root 2 all over the adjacent side of theta, which is 1. So this tangent of cosine inverse of 1/3, that's equal to 2 root 2. So let's do one more, and then we'll call it quits for today. So let's say you had, let's say cosecant of tangent inverse of -2. So I have tangent inverse of -2. So I know that the tangent of my value I'm taking of my angle is giving me a negative value. And tangent has to be between negative pi halves and pi halves. And so I know that this is going to be between negative pi halves and 0. So do the exact same thing that we had done above. You're going to choose theta to equal this inverse function, tangent inverse of -2. Take the tangent of both sides, we get tangent theta is equal to -2, or -2 over 1. We can write it as a rational number. Again, theta is in quadrant 4. So if we wrote our triangle, let's just ignore the signs. Tangent is opposite over adjacent. So opposite is 2, adjacent is 1. Our hypotenuse, C, is equal to the square root of 1 squared plus 2 squared. So I know my hypotenuse, C, is equal to the square root of 5. So now we're looking at cosecant of theta. Well, cosecant is 1 over sine, which is sine is opposite over hypotenuse. So cosecant is hypotenuse, which is square root of 5, over the opposite side, which is 2. So cosecant of tangent inverse of -2 is equal to root 5 over 2. This is where we need to be careful because of our sign. Our sign in the 4th quadrant is negative, so this needs to be negative root 5 over 2.